Hello, my name is Rusty Bascom. I'm a principal engineer with Electrical Consulting Engineers. Today I will summarize for you our paper, Design and Other Technical Considerations for Applying Cross-Link Polyethylene Transmission Cable to Retrofit into Pipe-Type Cable Pipes. The co-authors for this paper are Sarah Lacey, Charles Schupler, and William Lopez, all from PEPCO, and Soshi Masheo and Satoshi Ona from Sumitomo Electric Industries. In 2012, the Potomac Electric Power Company was investigating alternatives for connecting their existing Buzzard Point substation to the proposed new Waterfront substation, both located in Washington, D.C. Conventional pipe-type cable or cross-link polyethylene cable installed in duct banks were both considered viable options. During these early design stages, the utility also realized that manufacturing availability for pipe-type cables was diminishing in the industry, and that operating and maintaining these systems was increasingly becoming a challenge. The proposed new substation was approximately 550 meters, or 1,800 feet from the existing substation. The utility realized that this relatively short circuit length would allow an opportunity to investigate alternatives for retrofitting into a steel pipe, which would allow later servicing of their existing 500 circuit kilometers of existing pipe-type circuits. The utility contracted with the team to assist with design and implementation, including electrical consulting engineers for the electrical design, Dewberry engineers for the civil design, Sumitomo Electric Industries for the manufacture of the materials and installation oversight, and W.A. Chester for the cable system civil and electrical installation. As is detailed in the written paper, 4 extruded cable technologies were considered for retrofit into steel pipe. 3 cables pulled in from separate reels, bound cable cores with a common binding, conventional 3-core cable, or a triplex cable design. Ultimately, a triplex cable design was selected. This consisted of a reduced insulation wall that remained compliant with Association of Edison Aluminum Company electrical stress limits, with a ground path that consisted of a copper conductor and 3 aluminum tubes to provide a ground continuity path. Initial substation connections required 138 kV operation, but ultimately would become part of the utility's 230 kV loop around portions of the District of Columbia. 230 kV class cable and accessories were selected, but would initially operate at 138 kV. Consistent with the 230 kV pipe-type system of the time, 219 mm or 8 5/8" line pipe was selected. Phase 1 of the project, operating at 138 kV, utilized 1 circuit in steel pipe to meet the ampacity needs. However, constraints on fitting XLPE cable into the steel pipe would mean that 2 cables per phase would be needed to meet the ampacity goals for 230 kV operation. The civil infrastructure used on the system allowed for conventional XLPE cable if needed, and also supported the later installation of the second phase of the project. During construction and installation, the triplex cables were installed from 1 cable reel between manholes and between one of the manholes in the substation. 2 different manhole configurations were utilized. The first involved triplex cable to triplex cable, as might be encountered during a conventional splice location and a regular pipe-type circuit. The other configuration involved a triplex cable to individual steel riser pipes to simulate a trifurcating manhole that might also be encountered in a retrofit project. Parallel PVC conduits were installed through the same manholes for the second phase of the project, when the circuit would be converted to 230 kV operation. Commissioning tests followed AEIC CS9 recommendations for a 230 kV system, including an AC high pot and partial discharge monitoring. The circuit has been in successful operation since 2017. This project gives the utility experience with a simulated retrofit application and ultimately operational experience with the extruded and pipe cable system configuration. Actual retrofit applications will need to consider the typically longer installation lengths and higher ampacity of comparable pipe-type circuits. Phase 2 of the project is being designed now to install a parallel feeder of triplex extruded cable as the utility begins to implement the 230 kV conversion. If you have any questions about this project, please feel free to reach out to me at the email address shown. Thank you for listening.